This conference will now be recorded.
Yeah, so today we'll talk about an important concept in Hive called as partitioning. So before talking about partitioning in Hive, let me give you an example about partitioning in the real life. So if you take a house or a home can be partitioned into multiple rooms. You have kitchen, you have bedroom, etc. Right? Hey guys, can you hear me now? Is it better? Can someone confirm?
Yes.
Okay,
Yes,
okay.
Vanshu.
Sorry, there was a network glitch, so I had to switch to a different network. Sorry about that. I'll repeat the same example once again. So let us say that you wanted to meet one of your friend on a given day, and you just know only the street name. You don't know the exact house number, and you don't have any direct communication with your friend on phone, right? So what are the options that you have? I don't think you have any other option. All you have to do is to go through each and every house and figure out whether your friend is living there or not, right? But what if you know the exact house number? So it becomes very easy. You can directly go to that particular house, right? The same thing is happening with respect to partitioning in Hive. So if you go with partitioning in Hive, you don't need to scan through the entire data of your table. You can just scan only the portion of the data that you would require, because you have segregate your data, and then you are making sure that you are avoiding the full table scans of your data, right? So basically this partitioning is actually considered to be one of the performance tuning option in Hive. That is, if your Hive queries are running slower, then we try to introduce partitioning so that it will increase your performance of your Hive queries, right? So how will it increase? By decreasing the input output time required by your query, because instead of querying through the entire table, you are just going to query only a portion of your table. Right? So again, tomorrow I'll give you one more better example, but for now, let's actually go ahead with the hands-on. So there are two types of partitioning in Hive. One is called as static partitioning. The other one is called as dynamic partitioning. So let's talk about the static partitioning in Hive. So I'll go to my Cloudera Quick Start VM here. I'll try to open the terminal, right click anywhere on the desktop, say open in terminal, maximize, click on view, and click on zoom in twice. Launch Hive, hit enter. So the Hive shell has been launched. Let's see the list of all the databases, show databases. For today's session, I'm going to create a database called as Hive Partitioning. Create database, if not exists, Hive_partitioning. And just use up arrow on your keyboard and you can see that we have a database called as Hive_partitioning created. We will switch to that, use space Hive_partitioning. Then say show tables. So let's set the title for this terminal set title, give it as Hive, and I'll open other terminal set title. Let's say I would like to run any HDFS commands or Linux commands here. Click on view and zoom in twice. So let's go to the downloads folder. I'm in the download folder right now. We have this file called as orders.txt file. So this is the file that I'm going to use to create my partitioning table in Hive. So see the sample data. So this is the sample data that we have got. Based on this, I'm going to create a partitioning table now. I'll go to my desktop, say right click anywhere, say create document, empty file, Hive partitioning. So start creating your partitioning table. Create table. So the partitioning table name is orders_part. So start giving your column names. Order ID, which is nothing but the unique ID of your placed order. Order date. Then the next column is order customer ID. And then the fourth column is order status. And then comes my partitioning column. So partition by order month, which is of integer type. So then you have to mention row format, delimited fields terminated by comma. Just copy this, go to the Hive terminal, right click and paste it. Enter. I think there is something wrong. Let's copy this again. I think there is some syntax problem. Let me revisit the syntax again. It should be correct. Let's try again. Copy it. Clear the screen. Right click and paste it again. Cannot recall. Okay, I got the point. So basically, I'm missing out S in fields. I think that's what is causing the problem. Now this should be good. Yes, so I have this partition table created, and you can describe this partition table. Orders_part. So have a look here. We have the partition table, and you can see the number of partitions is showing as 0. And also look at the partition information. You can see it showing as order month. Right. Now also you can try one more thing. Show partitions, and then your partition table, which is nothing but orders_part. It doesn't have anything. right? So we have just created the partition table. We don't have any partitions added to that table yet. To confirm that, you can even take this path, select this, highlight that path, select it, copy it, go here, and then say hdfs space dfs -ls, and then give that path. So we don't have any contents right now because we have just created the partition table. We haven't added any partitions to that table yet. So let's say how to add the partitions to the table. We can do that by using alter table, table name, add partition, then your partition information, order month equal to 2013-07. So this will be my first partition which I'm trying to add to this table. Copy this, go to the Hive terminal, right click and paste it, enter. So we have this partition added to this partition table. To confirm, you can say show partitions and then your partition table name. So this is the partition that we have just added. Now if you describe this table, describe formatted orders underscore part, you should be able to see the number of partitions showing as 1, right? Now let's go ahead and check your HDFS location. So whenever you create a partition, it will automatically add a directory for you. So to confirm that, you can say dfs space -ls, right click and give that path. So have a look here, we have a directory added, right? It's showing as D, which means it's a directory, and the directory name is nothing but same name as that of your partition name, right? But now if you go inside this and then check the contents, you should not have anything. So just to confirm, so you can actually select this entire path, right click, copy it, just give me a minute, select this path again, right click, copy it, dfs space -ls, right click and paste that path. So there is nothing, right? So we have just added the partition, not yet loaded the data into this partition yet. We will see how to load the data into this partition shortly. But for now, can we create multiple partitions? Is it possible to add multiple partitions? Yes. So let me show how to do that. So alter table, table name, add, then mention your partition information, partition, and then give your partition information here. So I'm trying to create the partitions for the month of 08, 09, and then 10. So for 3 partitions, for 3 months, I'm trying to add the partitions simultaneously. Just give me a minute. Yeah, I'm back to the Hive terminal, paste that. So this should have created totally 3 more partitions. So 3 plus 1, totally you should have 4 partitions. Initially we had 1 partition, we added 3 more. So this should be showing you 4 partitions totally. So whenever you create a partition in Hive, remember that it will create a corresponding directory in HDFS. So what I mean is, so if you say describe formatted, your table name, so you can see that we have the number of partitions as 4. right? So now let's copy this path, the actual HDFS location path, select it, copy, DFA space -ls, and then give that path. So you can see that we have totally 4 directories here, because whenever you create a partition in Hive, it will create a corresponding directory in HDFS. Again, none of these have got the data. To confirm, you can use ls with -capital R option. That doesn't show you any difference because none of these partitions have got the data. So now let's see how to load the data into these partitions. So before that, we have to understand the data that we're going to use. So we have the file called as orders.txt, but there is one problem with this. This orders.txt file contains the data for all the months, 2013-07, 2013-08, and so on. Now we have to filter out the data such that we can get the data only for the respective months. So what I mean is, if you say grep is the command in Linux using which you can filter your data. So you can say 2013-07 and then your file name. So what I'm trying to do, I'm trying to filter out only the records which contains 2013-07 in it from the file called as orders.txt by using grep command in Linux. Enter. So this is going to get you only 2013-07 data, right? Now instead of printing this output to the console or the terminal, I wanted to create a file out of this output. You can use greater than symbol and then say orders_2013-07.txt. So what I'm trying to do, I'm trying to filter out only the records or the lines which contains 2013-07 in the file orders.txt. Instead of printing the output to the terminal or the console, I wanted to create a file out of that output by using this. If you use this greater than symbol, all the output will be redirected to this file and it will create this file for you called as orders2013-07.txt. So you can see that we have this file called as orders2013-07 created. Now just to confirm that things are fine, you can say head the file name orders2013-07.txt. I can see the top 10 records are showing as 2013-07. I can use tail and then the file name. I can see the last 10 records 2013-07.txt. It contains 2013-07. Right? Now what next? So we have the data. Now we have to basically load the data into the respective partitions. Right? Let's see how to load the data into the respective partitions by using load query. So by the way, if you try to query your table now, select star from orders_part, there should not be anything because we have just created the table. We have just added the partitions to the table, not yet loaded the data into those partitions. So now let's go ahead and try to basically use load command, load data local in path, and then give your file name. So under home Cloudera downloads, we have the file called as orders2013-07.txt. Copy this path, copy this file name, and give the full path of your files. Home Cloudera downloads, that's the file name, and then you mention into the table name is orders_part. Also, by the way, we have to load the data into specific partition. You have to mention your partition information as well. Order_month equal to 2013-07. Copy this, go to the Hive terminal, right click and paste it. So we have the data loaded into 2013-07 partition now. To confirm, you can say select star from orders_part limit 10. So you can see that we have an extra column called as 2013-07. That is nothing but your partitioning column. And also, where are we getting this data from? From your actual HDFS location. If you go and query your actual HDFS location now, you should be able to see this data. Describe formatted, orders underscore part. Now let's actually go here. Copy this path. Say DFA space -ls. Give that path. Okay, there is something wrong. Okay, I think 2013. Okay, there is a typo here. Okay, anyways, let's try again. I think there is a typo. So let's go here. So let me remove this. I think I have created this accidentally. I can say DFS space -rm. RM with -r option. Just a minute, guys. Just a minute. There is something wrong. 1 minute. Select star from orders part. Okay, we have the data for 2013-07. Let's similarly create the data for the remaining partitions also. I know today's session will be little hard. You have to accept that. That's where you have to need little more practice. I would highly encourage you to practice today's session at least 3 times. So basically, I'm trying to prepare the data for the partitions that we have created. So you can see that we have the data available. Now we can use the load command to load the data into the respective partitions. Let's do that. Let's copy this. Basically, I'm trying to load the data into all the partitions now. Copy this and go to the Hive terminal. Right click and paste it. So we should have loaded the data into all these partitions now. So to confirm, describe formatted orders underscore part. Let's copy this path. Let's copy this path. Say DFA space -ls. Right click and paste it. Let me try to run ls with -capital option. Now you can see that the data is loaded into the respective partitions. Can you see that? Right. So the point is very clear. So what have we done till now? We have created the partition table, right? And then we have added the partitions, and we have seen how to add a single partition. We have seen how to add multiple partitions, and we have loaded the data into all these partitions, right? And we have confirmed that the data is also available in those respective partitions. Now, is there any other way to actually insert the data into these partitions? Yes. To show you that, let me create one more partition. So I'm going to create one more partition now. copy this path, go to the Hive terminal, right click and paste it, enter. So now if you say show partitions, I should have one more partition created, show partitions, orders underscore part. So you can see that we have this partition called as 2013-11 created, right? Now to load the data into this partition, I wanted to create another table called a staging table. So that will be a normal table, not that won't be a partition table. That's going to be a normal table. So let me take this query to actually create a new table. So this will be a normal table, hence I'm actually going to name it as orders underscore stage, and it doesn't contain any partitions. I'm going to remove the partition. That's all. So this is just normal table that we are already aware of. Copy this, go to the Hive terminal, right click and paste it. So if you say show tables now, we should have the table called as orders underscore stage created. And then you can load the data into that partition by using load query. Copy this path, then paste it. So now let's try to basically use the load command to load the data into the staging table. The file name is orders.txt. Copy this, go to the Hive terminal, right click and paste it, enter. So we have the data available in the staging table, orders underscore stage, let's say limit 10. So we have the data available. So now let's actually load the data into the respective partition called as 2013, 11, right? But the problem here is you can see that it's again getting the data for 2013-07, right? So you start filtering your data. So to filter your data, you can use where class. So what I mean is, let me build the query here. Select star from orders underscore stage where order date like, so 2013 11 and then percentage, so that it will get me the records only for 2013 11. Let's try limit 10. Copy this, go to the Hive terminal and then paste it. So now you can see that it's getting me the data only for 2013 11. This is what we want. And now I want to load the data into the 2013 11 partition by using this. So I'm going to remove limit 10 because we have seen the data. I don't need limit 10 now. Then I have to use insert query. Insert into the table. Table name is orders underscore part. We have to mention the partition name exactly. So partition, we have to say orders underscore month equal to 2013 11. So this is what we want. So just copy this completely and go to the Hive terminal. Right click and paste it. Enter. Just a minute. I'm just trying to see the mistake. It should be order month, not orders month here. See guys, whenever you see an error, right? Whenever you're working in any project, first you have to look for typos, right? Most of the times the issues could come because of typing issues. Always double check your code that you have written by looking for typing errors first. So we have loaded the data into 2013-11 partition. To confirm that, what you could do is you could describe the table again, describe formatted, orders underscore part. So now have a look at your actual HDFS location. Just copy this path. Right click, copy, DFI space -ls, right click and paste that. So have a look at, this is where my actual data should be available. So you can actually go inside that directory and then check order underscore month equal to 2013-11. So this is where my actual data is available. So that's how you can load the data into a specific partition as well by using a staging table also. So whatever we have seen till now is called as static partitioning. So in the static partitioning, we try to prepare your data and you try to load the data into the respective partitions. So one interview question here, as we have seen that there are two types of partitioning: static partitioning and dynamic partitioning. So when will the static partitioning will be preferred over dynamic partitioning, especially with respect to data loading? Data loading is faster in the static partitioning compared with the dynamic partitioning. But there is a disadvantage with respect to the static partitioning as well. So the disadvantage with respect to static partitioning is you have to prepare your data, right? That's a tedious task, and you have to run multiple load commands to load the data into respective partition. And there is a high risk that is involved here. By mistake, if the user gives a wrong file name into the partition, then the data will be loaded into the wrong partition. Let me help you with the help of an example. So if you can go and check your query here. So right now we are trying to load the data by using 2013-07 data into 2013-07 month, right? But accidentally, if you make a mistake, here, instead of 2013-07, if I make it a 2013-08, Hive won't throw any error, right? Hive won't throw any error even if you're trying to do this. So basically, you are trying to load the data into the correct partition but wrong data, right? And Hive won't throw any error because Hive is something called as schema on read. So when you try to insert the data into the table, it won't throw any errors because Hive is called as schema on read. This is where we mostly prefer not to go with static partitioning the projects. We mostly be working on the dynamic partitioning. In the dynamic partitioning, as the name suggests, the partitions are created dynamically on the fly, as well as the data is loaded into those partitions dynamically on the fly. But you have to make sure that these two properties are set correctly, right? If you don't set these two properties correctly, then dynamic partitioning won't work. So let's go ahead and verify these two properties first. I'll go to the HDFS terminal here. So say hive space -e set try to grep for dynamic. So let me scroll a little up. So important properties that we should be focusing on this. So first of all, dynamic partitioning should be enabled. So to confirm that, take this property, set space that particular property name. Hive.exact.dynamic.partition should be set to true. So it is set to true, that is fine. That then you have to look at the next one, partition.mode. Select it, right click, copy, and go back here, set space that particular property name. So it is showing a strict, but this value should be non-strict, only then you can work on dynamic partitioning. So I'm going to change it to non-strict. So you can see that it has been modified to non-strict. So now we are in good shape to go ahead with the further steps in dynamic partitioning. So the next step is to create a staging table. This is already done. We have already created a staging table. And the next step is to load the data into the staging table. This is also done. Then the next step is to create a partitioning table. We already have a partitioning table. Now let us focus on how to load the data into the partitioning table from the staging table. And also another thing that you have to notice here is we already have the partitions, right? We already have the partitions created till 2013-11. Show partitions orders underscore part. We already have the partitions till 2013-11. I want to create the partitions beyond 2013-11. That is from 2013-12 onwards. I want to create, that is from 2013-12, 2014-01, 2014-02, right? So how do we do that? So I'm going to use my staging table to solve the problem. Select star from orders underscore stage, limit 10. Copy this, go to the Hive terminal, right click and paste it. So by default, it's going to get me the data from 2013-7 onwards, but I want the data beyond that. Just give me 1 minute. Yeah, so sorry for the interruption. So you can see that sorry for the interruption, guys. So if you can look at this data, we have the data from 2013-7, right? But we want the data from 2013-12 onwards. So that's where we have to apply the filtering mechanism. I'll copy this date format. Just give me 1 minute. I have Docker desktop running. I think that's what is slowing down the system. Just 1 minute. Sorry for the interruption. So I have installed some software. I think it is slowing down the system a bit. Anyway, so what I would like to do is I wanted to filter out my data based on the date column, where order date greater than or equal to. Then I wanted to mention the date format. So what am I trying to do? I'm trying to basically filter out all the records from 2013, 12. Right click and paste it. So this is getting me the data only from 2013, 12 onwards. Right. But if you look at your actual table, if you look at your actual partitioning table, orders underscore part, let's say limit 3, you have this extra column called as order underscore month also, but your staging table doesn't have that, right? It just contains only 4 columns. So somehow we have to modify our query so that we should be able to load the data into this partitioning table also by using staging table. That's where I have to use a function called as date underscore format. So this date underscore format is a function in Hive which takes two things. First one is nothing but the column name, which is nothing but order date, and the second one is nothing but the date format. So the date format is something like this, right? Year, and then the month form, right? So this is where we wanted to try out. So let's just copy this, go to the Hive terminal, then try this query. Now the data is looking good, right? Now I have to use this query. And by the way, one more thing which I have to modify slightly is I wanted to give a name to this column. So I want to give the name as order underscore month. Right, let's run it once again. Copy this, go to the Hive terminal, right click and paste it. So have a look here. We have the data available, and also we have this column called as order underscore month. We are in a good shape to load the data into the partition table now. So I'm going to say insert into table. Table name is orders underscore part, and here we have to mention partition and then order month. So this order month is going to get the values from the staging table, which is nothing but the below row. So as we have seen the data, I am going to remove limit 10. And before running this query, just make sure to see the number of partitions. Show partitions. Sorry, show partitions and then your table name, orders underscore part. And you can see that you have the partitions only till 2013-11. Now this will go ahead and create the partitions for you beyond 2013-11, such as from 2013-12, 2014-01, 2014-02, and so on. And also not only just creating the partitions, it will automatically load the data into those partitions. So again, I can say describe formatted orders underscore part, and let's get this directory, select it, right click, copy, dfs space -ls, and then give that path. Sorry, there is a typo. Let's run it again. Describe formatted orders underscore part. Copy this again, right click, copy it, dfs space -ls, right click and paste that path. So you can see that we have the partitions only till 2013-11. Now you will see that the partitions could be created beyond that. If I run this query now, copy this, go to the Hive terminal, right click and paste it, enter. Now you can see that it's creating the partitions as well as loading the data into the partitions. You can see we have the partitions. We have the partitions created for 2013-12, 2014-01, 2014-02, and so on. Not only that, we have the data also loaded. To confirm, you can say show partitions and then your table name. You can see that we have these partitions created now on the fly. Also, if you describe your table, describe formatted, and then your table name. If you can go and check your HDFS location, DFS space -ls, give that path. You can see that you have the partitions from 2013-12, 2014-01, 2014-02, and so on. Not only just the partitions creation, the data also loaded. To confirm, you can say ls with -r option. You can see that the data is also loaded into those respective partitions. So that's how we can deal with the dynamic partitioning. As the name suggests, it will dynamically create the partitions as well as load the data into those partitions dynamically. So there are some disadvantages with respect to partitioning. I'll talk about those tomorrow. I'll also give you another example about partitioning so that things are more clear. Guys, again, as I told, today's session is little hard. You have to practice little bit more, especially today's session. And it is very important as well. Okay, that's all I wanted to cover today. Tomorrow we will see something called as bucketing, and we will see how bucketing can take care about the disadvantages that we have in partitioning. So that will be the agenda for tomorrow. See you tomorrow then.